Good evening, everyone. Welcome, Obliterous, Hexgen, and Maegis. Oh, and Freya. Welcome. So, gotta move that over so you can actually see what it is I'm wanting to do. Give it a moment or two for a few more people to join before I start explaining what today's stream is about. Keyboard shenanigans! Yes! Yes! That's a good way of putting it. Well, so today's shenanigans are going to be twofold. So I've given a bit more time. The first thing we're going to look at is scan speed, with which we've got a couple of options as to how to try and fix scan speed. I want to first welcome Jiggly Girls. I want to first play with the idea that we've got about 105 picofarads of capacitance in each of the rows, which when we put that with 10k resistance gives us about 1 microsecond for the RC constant. I want to prove this by tweaking the resistor values downward. I'm going to go to two 10k ohm resistors on each end for 5k, which should give us a RC constant of 500 nanoseconds. And if I'm right, we can double scan speed, which is a good thing. The second thing that this stream is going to be about is reverse engineering the JTAG protocol as best we can, or at least starting to, because the protocol is entirely undocumented and proprietary. You can program ATX megaparts using open source tools, but you cannot debug them using those same tools. So, let's get into it. And while I'm thinking about it, let's get the virtual machine booting that we're going to need later. So this is a big reel of 10k ohm resistors. And I'm going to start down here with getting rid of the current 20k ohm resistors. So let's zoom in nicely on this, and there we go. There. So it would help if I remember to tell my phone, don't notify me about anything for now. Being burned out on doing things on your own. There's a mood. I wish my other half were here right now. But, I'm not allowed to have nice things like that for now. She's in the States, and currently not with us because she's out of it from having the vaccine yesterday. Something which I have no idea when I'll get to have. So what I've just done is I've just taken a 20k ohm resistor off. Okay, that's the next one. So what we're doing, my Aegis, is we're taking 20k ohm resistors off. So at the end of each row here is a resistor on both ends of the board. It's 20k on both ends for 10k total, because they're in parallel. And we're dropping these down to 10k ohm each for 5k in parallel. I'm doing this because currently good point, Freya. I'm doing this because currently we have around a max scan speed of about 1 megahertz. I can't go above that because otherwise the rows don't discharge fast enough. Or at least that is what it looks like. Also noticing that some of these joints look a little less than good. This is a PS900 by Metcow, which is basically a very fancy way of saying I can put as much heat in as I like and it will just keep going and going and going. Yeah, these irons are kind of nuts. Also, I'm sorry to hear that, Freya. You're really having a bad time of it right now, aren't you? Yeah, Freya's migraines are always bad. It's just what degree of badness it is. Well, yeah, and all of the other pain problems that poor Freya suffers. Yeah. I unfortunately, know how she feels. Fair. So this is a brand new set of 10k resistors. That's 4, 5, and 6. Ouch. That's quite a long time there, Blit. And yeah, you two would be great pain friends together, cause yeah, well, the pain friends are useful when it comes to seeing the good in the owl. I'd really rather not have a resistor decide to tombstone like that. Hmm. Thanks. Tombstoning is not usually that bad. Like, I'm doing this by iron, so I can fix it, but it's just a pain. As you are currently getting to see. It doesn't help I've got a lot of flux on the board, which is making this quite difficult to see what I'm doing. Okay, that looks good. I can't really feel the resistor, so that's good. Yeah, Freya is very good at puns. I'm sorry, as I know that's also your thing. But, I wouldn't want to put this on top of the big fryer. That would destroy the board. Just cleaning the tip of my tweezers because they were a bit meh. There's 2, 4. Where's 5th one gone? Oh. Oh well. That's gonna be fun to go and find later. Ah. Okay, that one went on a little better once I got it aligned. There we go. Yes, I just used a lot of solder, but... Yes! Okay, next one. I love how when you say, oh, I was doing some DDR today, my immediate thought took me to frickin' double data rate memory, because, you know. Anyway. Oh, I found the other resistor. Apparently I managed to, like, palm it off the desk on the bottom of my hand or something, and I only just noticed. That resistor doesn't want to go anywhere right now. realizing I've just been working off camera on you. Don't mind the car noises out there. People have been rather loud and proud today, and it's kind of annoying because I've kind of had a headache too. Well, it's more like my shoulders have been giving me a lot of problems today. I'm more feeling like Obliterous than I am like Freya, but oh, that's good. For me, that was an extremely loud, someone not quite knowing how to actually really control their accelerator noise. Yes, you did manage to respond to yourself. Because Twitch. It'd be really cool if this resistor would go flat. Whatever. Good enough. A blip probably wouldn't want an air horn. Oh, okay. Oh jeez, you took... Oh, okay. You took a train air horn and you put it on a car. Okay. Having... Yeah, ship air horn at the end of the day, whoopsie. Oh, come on. I can't get it to actually solder that end of the resistor. That's much annoying. There we go. So that's one end of the keyboard now done. We now get to pull these resistors here off, which is going to be fun. They're kind of a little all over the place because of the way that the routing works, and do the same thing on this end. And then we got to find out if it's indeed increased the speed at which we can scan, which it should have, but should and has are two different things, and we are going to check. I actually don't know what LD stands for in this instance. I sold it too easily, huh? I mean, I've been doing it for years. So there is that. So we've done 1, 2, 3, 4. There's another one. Those 2 gig kits are good. Where's the last one? Ah, right, it's all the way over here. Okay. One, 2, 3, 4, 5, and 6. They went flying. That's gonna be a pain. Yeah, just sending 10k resistors flying all over my desk. Don't mind me. Talking of allowing more boost and therefore more acceleration, reminds me that I've had this song stuck in my head for quite literally the last 2 days, which, because synesthesia, I experience as kind of very much like driving my own car, which very much, you put foot down and it just goes, and it keeps going, and it doesn't let up, which is great. So, song that feels just like that. That's, yeah. It's great. Thanks, Brain. Oh. You saw one of the resistors just below Toru. I can't see it. Interesting. Oh, okay. Fair enough then. The character you mentioned, by the way, is Toru. I can't pronounce that today, but anyway, she is a dragon lady and is one of the lead characters of Miss Kobayashi's Dragon Maid. Specifically, she's actually the titular dragon in question. And very cute. I don't know that I have. It sounds like something I want to read, though. Excellent. Get the next one in frame for you. There it is. I'm just super happy that a new chapter of Kumo Deska Nanika came out today. And it's good. Oh, you are doing some serious work on your car. I don't want to ask what brake horsepower it's at, do I? Also, welcome, JK Ivy. Welcome to the stream. The next one is this one over here. And then I can turn the board over and try and find that last resistor that went flying. Jesus, Flit. Jeez. That's a lot. I don't want to know what your miles per gallon are either. It's gonna be quite low. What's the displacement? No, I'm surprised. That's higher than I thought it would be. Well, wherever that 10k ohm resistor went flying to, it's gone now. I'm just gonna get a new one out. 2.2 litre, okay. Less mad than I thought it would be based on the initial stat. Makes me want to do stuff to my car even more, which I can't yet do. Sad. No, that's fair. I mean, it's pretty undrivable at that point if you're in, like, stop-start traffic, right? Well, and that. Oh, I'm well aware of that. It's the same idea as just because a power supply can supply an amperage does not mean that it will, all the time, be generating that kind of amperage. I think of it as more like a rating than a... And especially as you've got controls for, like, your boost, right? So you can choke out some of the boost and therefore generate less. Which drops the horsepower. Okay, so with all of those resistors in, yeah, you get boost control. Let us power the board up and make sure everything's still happy and works. Here's a cable I prepared earlier for this reason. And if I press down a whole load of keys at once, like if I press down the full WASD set, we can see, yep, no ghosting, and it's all nice and responsive, so that's good. Thank you. I can tune the blue. The green is just straight up the green of the LEDs. That's just the green that is in the LED itself. It's very nice. Let me get the iron unpowered and out of the way, and we're going to change the firmware. So I'm just going to move a few things so I can actually work on this. The thing we want to poke is this. So this is all to do with generating enough delay between powering a column and respectively then seeing if that column generated a given set of button presses or not. Which is where the discharge comes in. If the button's not pressed, it needs to be discharged sufficiently to read as a 0. Yes, still working on the firmware. But the firmware is functional enough that we can just do arbitrary random testing at this point, and like all of the key matrix handling is working. It's just not going to my desktop and changing what's on my screen, you know. Gonna put my soldering iron away so I have a little bit more room on my desk. That's an impressive upgrade. To be fair though, I am happy with my, by comparison, piddly 120 brake horse. Suits my needs very nicely, and I get 45 miles to the gallon. Which is a good amount of MPG. Anyway. So, let me just quickly fix the fact that my camera is slightly cockeyed. Here. Sure. Mine's not running on a turbo. And it's factory. The really scary part with mine is that it's a 1.2 litre 3-cylinder. So what I've just brought in here, this is the box you usually see on my streams, which is the JTAG Ice 3. This is Glasgow. It's wearing a little hat right now, which allows me to chain JTAG coming out over this from this box. And it's just got these 2 headers on it, which tap onto the Glasgow header and then go back out, so that we get a good signal integrity, so we can run this at 4 MHz. This then plugs into the keyboard, which should go in, it'll be that way around. And then we can put power to Glasgow. Put power to the JTAG Ice, which fair enough. Now, helps when I don't have the cable upside down. So, good that. And then we can power the keyboard up. And we should see... Yeah. This can see the host, so it can see the board, which we're good there. And then I should then... if I... do a Glasgow list, we should see the Glasgow. We do. I am looking to use the analyzer output for once. So, we are using port A. I think. Yes, we're using port A. We want to fair enough, Obliterous. We want to... I think I want to say I want it to mirror the voltage. So if I do Glasgow voltage... Yeah, we've got vSense here showing 3.3 volts. So this is because I told, I routed on the shield the voltage to... the voltage to the sense pin. So we can tell it to mirror that, the port power. We then want to use which pins is it that I need to use? I put the info for that on the back of the board. One moment while we open Nightly and find out what the pin out of the board is. Oops. Zero, 1, 2, 3, and 4. So, in theory, this is everything we need when I combine this with the build system for the keyboard, which is now done building, to do a capture yeah. So let's see what happens. Okay. FIFO overrun, shutting down. Oof. Well, I'll come back to that in a moment. Right now, I'm gonna first see, are we still good on timings here? So, I haven't got G lighting up, and I haven't got apostrophe here lighting up. So that's a good sign that we're able to handle a sufficiently large number of key presses. Like, I can really press a lot of keys down and it's happy. So we've been able to speed up the loop by about double, which proves the theory of the RC constant. Thanks, by the way, Obliterous, for calculating the approximate 105 picofarads. Actually, it was nearer 110 for the rows. Yay! We just made it go faster. Now we need to figure out why on earth Glasgow had a bad day. Rather than doing anything in the console, let's load up Pulse View which of course went onto the wrong screen. And let us open a value change dump. Hey Eston, welcome, welcome. We've done the swap out on the backside, and we're starting to do some of the reverse engineering stuff. I made Glasgow very unhappy, so this could have been quite entertaining. We've got 5 logic channels. Oh, I'm about to have this seg fault. Hey, yikes. I ran my machine out of memory. Let's try that again. Pulse View and VCDs are not friends. I wonder then actually if I should use GTK Wave. It might be easier. Well, for some value of easier. New tab. I would love that, Freya. You know that. Let's... drop those in. Oh, wonderful. It buggered off when, I really want to have these as multiple separate traces. Okay, Eston, as you're here, I need to ask you a question. I'm trying to use the logic analyzer and got this. How fix? Because this is a problem for me. I would like it if I could tell Glasgow that there's a clock that it can use on pin 3. Good question. I don't know. That almost felt like it was more like a FPGA side of things thing. Fun. I mean, it's on its own USB hub that has nothing else attached to it right now. So it has all the bandwidth. Like, I want to go pressing the up arrow. Nope, wrong keyboard. The other one I could possibly use in this case is the JTAG probe, but it doesn't feel like it's the right one. I basically want an analyzer that's going to use the clock to create the BCD rather than just free run. The yeah, see, the Glasgow JTAG probe applet is active. I need something passive. Well, we can always try this a second time and see what happens. Yeah, see, it instantly dumps out when I ask the JTAG programmer to do its thing. That was a little bit bigger this time, 15 kilobytes, but... I really want to have this as 4 individual wires. Does this work any better this time around? Kind of. Well, there's our clock, happily doing its thing. So this is a good sign that the interposer works. Yeah, that's very weird. We don't get anything after that, and I didn't mean to do that. So we get the clock, that's good, but we don't get anything else really. Pin 1 goes low. Pin 1 is... TMS. And then it just dies. Eston, I'm gonna have to write an applet, aren't I? Let's go and find open folder, programming 1-bit squared, Glasgow. So there's the JTAG Pro backlit here, and the analyzer applet. I'm going to create a new JTAG analyzer applet, I think, in response to this problem. However, I'm going to move the board to my right, because having it right in front of me is going to become a problem in a hurry. Well, coffee, buy it, you can't rent it, is better than it living rent-free in your brain, I guess. Oh, obliterous. Oops. Just tap a control and it turned the camera off. Oh, I love coffee, so coffee, yes please. Yeah, tea is also acceptable. Just trying to think of where I can put, like, the boxen that we need for this. How does lemon tea even work? I'm intrigued now. Okay. Well, you're no fun. I love tea, so... Okay. Hot water juice. I don't know. Oh no, we're reminding Obliterus of his pranks. I'm gonna plug Glasgow in through my my USB analyzer, but only because I just need the extra USB connectivity on my desk rather than coming from elsewhere. So I now need to go and mess with the backside of my computer. 1 moment. My USB port situation is awful, which is why I really need that USB port thing I keep talking about doing. You know, that thing. Oh no, this is a problem, I guess. It's just something I can fix. It's just, the fix is a 120 or 240 watt power supplied USB hub with Type-C connectors all over it. Because we need one of those. Take care, Hextron, and sleep well. Well, so one of my requirements for the hub idea is that every port needs to be able to supply the full USB PD spec 20 volt power every port needs to be full USB 3.0 minimum over Type-C. So, you know, a small hub project. I won't need very much of heat sinking, actually. 4 to 8 obliterous. But the heat sinking for it's not so much because I'm doing DC-DC power supplies. That's the plan, at least. Rather, I will do. So, let's put Analyzer and JTAG Probe over on one side, so we have them for reference. Let us also... How does it get a listing of all the applets? Looks like it might be automagic. Take care. Okay. No obliterous. Double that. For 4 ports, 20 volts, 2 amps per port. 40 watts per port. There's 120 or 160 watts. Oh god, no. No, that's not full USB PD. Full USB PD is 20 volt. I mean, even if you say it's 20 volt, 1 amp, 4 ports... I'll have a look at that in a moment. Kind of Freya, but also no. Anyway, what's this thing, and how annoying would it be? Yeah, see, this is a USB 2.0 hub. It does not do 3.0, so that's already a strike on it. But otherwise, that's not bad. Also, this is a proprietary thing, so like, yeah. I intend mine to be fully open hardware. Yeah, see, the 3.0 USB-C hubs thing is basically what hubs. The hub chips exist. Usually you can only get one with like 1 port at full power, and then the rest are all base spec. And I know why they've done it, because I know the power supply is going to be very expensive to do. But also, so... Oh, there's a lot of logic in here. Don't know why that didn't copy the first time. No, it's more like the power supply required is, chunky. Well, the analyzer here is really quite simple, so that's nice. Capture JTAG traffic. No, because the power supply will need to be always on, for example, and I could derive it from a 12-volt rail for a PC power supply, but it would be a royal pain in the ass. They're just not designed for that kind of power draw at those voltages. And also, 12 volts having to convert up to 20 volts for the 20-volt modes, but then down for the 5-volt modes. Ew, no. What you do for this kind of power supply is you generate 20-volt power supplies. Sorry, you do one big 20-volt power supply from mains at the full current, and then you have small switches in. Well, actually, it'd be a little bit more than 20 volt. It would probably be 24 volt, and then you put a switcher in front of that to the port that down converts to 20. I'm trying to remember what the steps are. There's 20 volts, there's 5 volts, but there are some ones in between as well. And there are steps that you've got in the power delivery spec. And you use the power supply design on the board to get your final stepping. Yeah, that looks about right. Yes, mains-driven switches are quite easy. Capture JTAG traffic of the analyzer applet. PPS compatible mode? I can't remember what PPS stands for in this instance. No worries. So we're going to need the VCD writer. From in my gen, import everything. We're going to need that. Oh! Programmable power supply. Yeah, so what I would be designing effectively is a programmable power supply, but it's a programmable 24 down to one of the power supply. And then replicated 4 times, because each of the 4 ports will need to be powered separately, or 8 times if I'm doing an 8-port version. That's only one part of the problem though. When I said Type-C, that automatically means I need very high speed pin muxers for the super speed data plus data minus pair. Or pairs, sorry, because it's a transmit and a receive pair. On every port. And then you've also got the whole power delivery on every port, which is another chip, on top of the hub, and I've been doing my research. It's a lot of work, but it's worth it, in my opinion. Okay, that gets us to a point where this will run, which... Yes. Maybe. There we go, we've got our shiny new. So, def add build arguments. Okay, that's actually really cool that that added all of that code for me automatically, save for getting the tabbing wrong. And putting a return where we don't want one. So, the actual arguments we want... Now you see, that would actually be really, really handy, as that's actually one of the things I know I'm going to need. What is the default? That would be really cool. I would like to do this project with someone, so that would be amazing. Let's do the enumerate thing. I think that should do the trick, so that if we do JTAG analyzer help, we should see one required positional argument not found. Oh, is this because I forgot to mark this as class method? Probably. Yes, that was one of the problems. So I know, Hard Crash, that you're trying to like help me not have to do a project, but I still want to do this. This is neat, however, that's a problem right there, because the controller chips that you and I can lay your hands on do not do that. Yeah, this is an interesting one, but I want to avoid I2C based things. I'd prefer like a SPI bus. I was looking at, for example, this chip, this monster of a device, which that would be the hub. Not that you can currently buy one of these, but you know. There was also... let's get these loaded. Come on, final website. There was this one. This is another option for 3.0 hub. And this one, which hilariously is drop-in replacement for the other one. Only slightly bigger. Or some weird shit. But they're actually pin compatible with each other. So yeah, I've already been doing some research and trying to figure out what is or isn't possible. If I were to go with something like that I2C controlled power delivery device, I will have to write custom firmware in another microprocessor that somehow has to talk with the hub. And it gets very convoluted in a hurry. Which makes me think I actually want to implement my own USB power delivery stuff and connect the power supply for the port to that PD control chip. However I end up doing it. But that means I have to do downstream facing port power delivery from scratch. Or something. And I know it's madness. Thanks. I see who my real friends are here. I'm joking with you a bit. I know what I did wrong here. Extra pair of brackets are needed to be able to take enumerate to taking a tuple. Okay, the width thing is required. Why? That's very frustrating. Oh, true just gives you the pin number. Okay. Cool. What order do these actually appear? So TDI, TMS, TDO, TCK. Let's put them in that order. And then we also have a optional reset pin. So access, add pin argument. I think I can probably get rid of the width argument now. Or not? Wow, really? Then how on earth is this code working? Huh. I'm trying to work out why that would work. Anyway, whatever. Oh, I see. I'm a little fried right now. It's not pin set, it's just pin. There we go. So that's TDI, TMS, TDO, TCK, TRST, which is not really TRST in this case, but it's fine. Actually, I'm gonna rename that. It's actually just pin reset, because this board doesn't have a TRST as such. We then have build, which now can just do a pass. Add run arguments. Yeah, we're gonna need that. And then we also have async def run. Nope. That one, thank you. So, we want the USB interface, device multiplexer claim interface, Okay, that fixes most of those problems. Analyzer interface is something we're going to need to define. Now that'll do, just so we have something there. Build, it needs, again, to claim the interface, so we'll grab that code. Which solves the problem of what Mux interface here would be. We then also have sub-target thing, so we've got to still fix that bit. God, this gets complicated. Analyzer sub-target is this, which is the okay, that's the nmygen elaboratable. I know what I'm doing with nmygen at least. Most of the rest of this is me copying boilerplate for what it's worth. So we've got event analyzer. So this is based on top of a thing called event analyzer. What we actually want here is more like a JTAG interface component, which happens to generate value change dump stuff based on the clock changing. As for the analyzer, let's just return M for right now, so we have a module which we can then populate with what we need. So this is JTAG, analyzer interface. We can now define the sub-target, which is the actual bit that does work. pin sets here, that's going to be this, the analog to this. So they've done pins here, I think, to... Yeah. Ah, and it's pins, not pin sets. Okay, okay. That makes sense. We got TCK, TMS, TDI, TDO, reset as the pin group. In FIFO. Oh, I see why that's been, comma's been put on the end there, that's fine. So that gives us the ability to actually build some hardware, even though that hardware is currently do nothing. That gives us the ability to run that hardware, even though that hardware is do nothing. What am I missing? Add mutually exclusive group. Oh right, we've got to do the pull-up, pull-downs. Har har har. We also need the VCD file part. Okay, and then there's also interact then. Which... what are the parameters? Yeah, so what I'm planning with this is that rather than just capturing what's on the raw wires, we're going to do a little bit of pre-processing in Glasgow itself so that we can use the clock. We're going to only capture while the clock is running, clock is externally provided, and we will buffer value change events up to the FIFO to put into the VCD. And they will be to do with whenever the clock has changed. Oof. I'm sorry to hear that, Freya. Take care then. Sleep well. So the idea with this is going to be, we sample the data rather than just straight up putting the clock in the VCD, etc. We will sample the data on the clock, and we'll only put the sampled data in the file because we know that JTAG works with its clock, so we can basically implement a small part of the JTAG state machine enough to get us value change dump and go from there. So this is going to be, sure, we'll go for 1 nanosecond. It's an arbitrary value, really. Check values is going to be whether or not things are in... yeah, check values true. That doesn't say what check values does. That's quite annoying. Well, that really doesn't help me know what check values does. But White Quark turns it off, so I will too. I'm betting it's to do with the validity of the values, but because we're guaranteeing that we're going to generate good values, then we don't care. Well, let's write some hardware then. We don't need the full tap interface. We do need the clock stuff. Actually, that's an idea. Let's have the bus as a separate thing, and we'll do kind of subcomponents. We'll first get the physical signals sorted out, because we only need the input side of things and so on. And effectively elaboratables are free. Actually, I think I'm going to call this SRST because this is technically software reset. Do I want to change that on the external interface? Probably yes. So we want to join onto self.tck the value on pads.tck I. Same for each one in turn. Oh. And these will need the flip-flop synchronizer thing. That's right. Because otherwise we will get some interesting problems on the synchronous domain. So this is actually, I've got sub-modules that we need to add everything to. of a pain, but, you know. There we go, and then we need to return the resulting module, because otherwise this breaks horribly. Oh, not self. M.submodules. Let's call it bus, yes. JTAG analyze a bus. There we go. Now what is the adapter doing? Okay, so this is to do with taking the internal signals and IOing them with the JTAG pins. I probably need some of this. But instead of it being for generating a clock, we are actually trying to recover a clock. And then do VCD things. What does Event Analyzer do? Holy. I'm just having that moment where White Quark has written something amazing and trying to understand how to make use of it is going to suck. I'm trying to wonder how important it is that an event analyzer is the thing that produces the data that's coming out here. That doesn't provide me any help. That's annoying. IDE won't help me with this. That's kind of obnoxious. That's because this is the function. Oh, and it's an ABC matter. Of course it is. B demultiplexer. Direct demultiplexer. Which is one of these. And how does its read work? Okay. Is that then that because we, on the multiplexer, side get to specify how that data is formatted. This is my first time actually doing a full Glasgow output from scratch. So this is a learning curve for me, a very big learning curve for me too. Signal.like. Huh. Ah. Hello. This all feels like it's just straight Python. This isn't running on the FPGA. Okay. Alright, so this is... yeah. That's fair play, Element. Also, welcome to the stream. Thanks for watching. I am presently having that moment of, wait, what has White Quark managed to do here? Why is she blowing my brain again? Because I'm trying to figure out... Yeah, see, this here is generating, did this pin change, and if so, then we trigger the event source, but I'm not sure how event analyzer works. This is... because this is a friggin' giant chunk of code. Like... that's an insane amount of code right there for value change dump stuff, and I don't know how it structures the data that goes into the FIFO. I can see that data and trigger are signals, so it deals with event source as a type to hold signals to observe. Self-event sources append. And this uses do finalize instead of elaborate, which is kind of a little bit obnoxious as well. I'll also temporarily turn off the camera view just so you can see a bit more of the code. Event FIFO. Sync FIFO buffered. There's then this delay FIFO. output FIFO. Output FIFO is the... Okay, output FIFO is the one that comes in here, which... Okay, that's the FIFO that we get from the multiplexer, which is our interface up to the host. So we've got report delay, report throttle, report event, and is this using... Yeah, this is using MyGen compat. So this is MyGen style code, which is also a pain, because this is not how you write NMyGen anymore, and hasn't been for some time. Priority encoder, data in is... So this is a constant to let the PC know that this is a event, rather than like a throttle or other condition. Yeah, report special, report event. And then this is the data in the event encoder. Which is a priority encoder. Okay, I think I now know what I'm going to do in this instance. We are going to need something a bit like this, but instead of it generating on every single signal, we're going to use TCK to do some of the grunt work here. I can turn TCK into a clock. Do I want to do that? Probably yes. So we'll call this event adapter is an elaboratable again. This is going to need to take the bus, which in that regard it's very much like this side of things. And then the in FIFO. When I can spell. So this, to explain a little bit with what I'm doing with the NMyGen side of things here, M equals module like this is an established standard in MyGen for defining a thing that can be elaborated into hardware to do something in its elaborate call, which is the required call you have to implement. We then return that module. That just makes it so that this, oops, this is now a valid elaboratable thing. And MyGen will say it does nothing, but I can elaborate it to hardware that does nothing. Great. Once we've done that, we then have a need for, in this case, we're going to need to generate some signals. We have TCK, TMS, TDI, TDO, SRST, and these are the inversions of each. I think I want to do it this way. Yes, I want to do it this way. Are equal to the self.bus versions of those signals. We'll actually properly split this out in just a moment, because I actually need to take a copy of that local. How do I want that bit to work? So I could either store the bus directly, or I can store the signals from inside the bus in this type. I think I'm going to do the latter, which makes this a little bit more complicated, but will be better for us overall. So this allows us to then say here self.tck, self.tms, self.tdi, self.tdo, self.srst. So we now have local variables for each of those inside the elaborate call, which I hate to call it a call because it's not really like programming like normal, but sure, we'll call it a call for right now. We then need to create TCK R, for example, which is going to be a signal. And finally SRST. And what we're doing with these signals is we are creating time-delayed versions of the input pad signals. Actually, I'm going to slightly redo this. TDI, not TDO. And then we can then put each of the delay signals next door to the non-delay that it is for. Kind of like that. There we go. So what we can then do is, in the synchronous domain, so that's FPGA clock, we then do time delaying. This is to generate whether there has been a change in the value of the signal, which we're going to need in order to reduce the number of things we report back to the host each time step, which also makes it closer to a value change dump, which is quite important. So this is TCKR is equal to TCKI, and we do that for each of the signals. So we do TMS, TDI, TDO, and SRST. So we now have time delayed versions of all of our pad signals. Actually, do I need to do TCK? No, I don't need to do TCK. That would have been a mistake. Because that's the one that's going to drive the entire VCD process. Yes. So the next thing we then have... so instead of doing this event source stuff and then having another subclock type here, which is... we can do priority encoder stuff directly. However... I need to remember how to generate a clock domain. Luckily, I've done this once before. Kind of. So we have domains, OPR, clock domain. There we go. That's how we do it. So you make a clock domain and then you bind the clock for the target thing to that domain. Whoops. Domains, not just domain. And then we also need to then say... combinatorially make it equal to TCK. So what we now have in the FPGA is we now have the ability to treat TCK as the actual clock it is. Now we have to be a bit careful because now we're going to go multi-clock domain, which is always risky. But I think it's worth it here. Is it? That's... I'm just trying to consider some stuff in my head. Yeah, really. It gets pissed at you if you try. Because that allows us to do m.d.tck. Actually, let's call the clock domain JTAG. And actually that allows us to do this on the... thank you. Instead of having to do flip-flop synchronization here, I think I want to do it right as we need it to go and put things into the FIFO. Although it's a FIFO, so it's going to do domain resynchronization anyway, so we're good. We can work on the JTAG time, which allows this instead to now be m.d.comb again. God, I'm amazed that I'm having to rewrite code that I've only just written, but oh well. MS, TDI, TDO, TRST. It happens when you're writing hardware and you're trying to think about how you want the hardware to work. I'm just saying. This is... yeah. Okay. So we have a thing that groups all of the pad signals we need. We then pull all the pad signals out and we make time-delayed versions of them on the nice leisurely 4 MHz. Async FIFOs are fun. So... oh no, they're actually fun in this case. Why would you have a priority decoder? Anyway, I want to go through a priority encoder or not. I don't think so. I think I just want to enqueue the actual data that's seen by fucking TCK. Which means actually we probably don't even need to do all the time delay stuff. Where's our in FIFO? So this is going to go through... manually reporting it. Oh my goodness, this code on the right hand side is generating so much USB traffic that we can avoid just by reporting the raw JTAG byte that we're going to create. Okay, that's actually a nice simplification then. So, m.d.jtag, well actually, we go in the JTAG domain. Oh, no, hang on. This is done the other way, because with m.if self.infifo.writable, m.d.jtag self.infifo dn, which is the data input to the FIFO, gets to be equal to data. Actually, I might put that on combinatorial, because the only thing we're going to report is the data, and it's whether or not we are enabling the right to FIFO or not. No, I still actually will do the time delaying thing. I've just realized what I can do here. So this is m.d.com. So we combinatorially take the data vector that we're going to be creating in just a moment, and we assign that through to the input FIFO, so that's the FIFO to the PC. If it's writable, and there is a change, will be the change that we need to make there, then we want to momentarily burst data to the FIFO. The question I have, I can't do it that way, is going to be what is the clock domain for the FIFO? Get in FIFO from the FX2 crossbar. There's the FX2 crossbar code. Okay, so we can say clock domain equals and then do it that way. Bingo, I think. Yeah, because this is passed through. My brain is starting to hurt if it couldn't be told or figured out already. So this is... we want trigger signals. So this is four bits of data. 1, 2, 3, 4. Yes, 4 bits of data. And triggers. So we need to generate I can use cat in this case to concatenate TMS I TDI I TDO I SRS T I together. So that gives us the data signal we need. We then also need to generate a trigger signal. Actually it's just a signal, not a signal 4. Oh, and this is an n-mygen and, so it needs to be double ampersand? No. I don't recall. No, single ampersand and, that's okay. We can do that. That's not a syntax error. So what n-mygen does is instead of using the Python and using dunder and, it uses single ampersand instead to create the overload to be able to do gateware anding. It's not a bad solution actually. But it does throw me for a moment going, hang on, how does this work again? So I actually am going to do a triggers signal as well, because I need to generate a series of true if value change signals before I can merge them all down into a single signal. We can do this all combinatorially, which is nice. So triggers.eq concatenation of TMS I not equal TMS R TDI I not equal TDI R TDO I not equal TDO R SRST I not equal SRST R. So there's all of our trigger signals. If any of those go true, high, we know that the value changed on that pin. We need to record that. We can then do trigger.eq triggers any. Yes. So what any here will do, or should do, is altogether all of the signals inside the signal for us and just spit out a bit. And we can then use that one bit in logic tests, etc. Makes life nice and easy. So we now have got... Oh, hiya! Welcome, Mackie. We now have what is effectively our event source data and trigger. The really funny part is it's nearly 6 PM for her. The Glasgow situation with logic analysis, Aki, has driven me so far mad that I'm having to write my own JTAG analyzer applet. Help! The problem is that if I try it right now and do a run, so this is me trying to reprogram the keyboard. So we boot up Glasgow's logic analysis. Cool. Now we hit program. Oops. We overrun the Glasgow FIFO. Hard. I now have a probably 15 KB, 18 KB BCD. And if we look at this in, let's say... Oh, I know exactly why that's happening now. You're gonna hate it in a moment when I explain it. But if we look at this in GTK wave, just for example. And... so... this burst right at the end here. That... Ooh. God damn. This is just the clock going high and low. Oh, it's such a tiny amount of data anyway. What it is the clock is just going high and low in that. Let's actually see if pause view will work for us. For this. Did I just crash pulse view? I think I just crashed pulse view. Kind of. That was fun. Yeah, it's currently using a ton of my system memory too, which is just fantastic. So if we go looking at what happened there we go. There's just clock pulse changes. That's all. That's the only thing that was happening in that trace, was just the clock wiggling. But every single one of these, both up and down, generates a trigger and a multi-byte packet via this horrible state machine here, which uses a priority queue to send the data bit at a time. RIP. So what I'm doing instead is I'm going to send whole bytes to the PC that are clocked on the JTAG domain using TCK, and we will do the chunking on the PC, but this should drastically reduce the amount of USB traffic, cause yeah. Whoops. In actual fact, that actually makes me think, do I want, because that will be byte at a time, do I want data to be the real underlying data and the bit that changed, as we've got that in hardware? And I think the answer is probably yes. Because data can then be 8-bit wide, which should match the bitness of the FIFO? Let's find out. So we've got make FIFO. Compat async FIFO. Width. Yes, width is 8. So yes, we have 8 bits to play with, so we can stuff the underlying signals and which one changed into 1 byte, which we then get out here. So let's make that happen. So we've got we need to then register the signals. And then we can then do the whole trying, finaling. This is finally VCD writer. Welcome back. Now the timestamp thing is going to be a little bit of a problem. because we aren't getting the cycle. Oh, we can set cycle equals 0, and then we can figure it out from there. You want to what? Why would you want to do that, Obliterous? So, we have... we don't care about the overrun thing right now. Okay. Value equals await iFace read. This is actually more like data equals. We then want to pull out the individual change bits. Now, I don't recall what that translates to. Yay! Kyo wa takusan no kawaii neko. Lots of cute cats today. I approve of that. She is very cute. And a cat. iFace there is... yeah, it's that. Aww. Adorable. Okay, so this should be the JTAG interface. Right? So this read is this read. Oh, that's amazing. So I can do all of the data splitty stuff in the read class. So we can have TCK, sorry, not TCK, TDI, TMS, TDO, SRST equals that. Well, actually, that's the wrong pin ordering for how we're encoding it in the hardware. Let's try and keep it in hardware order. TMS, TDI, TDO. And we can have each one of those have a changed equals, true or false, and value. Not self, it's just that. Well, actually no, because I need to do this in depth Dunder in it. And this is value. Yeah, we'll go with 0. Ah. Accidentally hitting all the wrong keys. Changed.set even. so that gives us a thing that we can then unpack here. Actually, that's better. Yeah, because I'm overthinking this. There we go. So... bit 0 is going to be TMS, 1 TDI, 2 TDO, 3 TCK, sorry, SRST, I think. What I'm trying to do here is I'm trying to make it so that when we pull data out, it becomes a iterable process to pull out all of the bits and the change information. Actually, do I need to... I don't need a bitmap, I just need to just iterate over the bits in pairs, so it's a low bit, the low bit of the low nibble and the low bit of the high nibble are a pair, and we pull them out as pairs like that. Using 4-bit in range. Hi Steffi! Welcome, welcome. I've ended up having to write a new Glasgow applet to debug or to get the value changed information I need. Thanks for the follow, M5ZS7K. Interesting username. Thanks, and welcome to the stream. Thanks for following, welcome to the stream. I am, as I say, currently trying to write a Glasgow applet to more smartly... Oh, hi, thank you. Welcome, Raiders. Yeah, I'm currently trying to get it so that we can pull JTAG data from the JTAG bus in a sane manner using Glasgow. Which is proving fun. I might be slowly going a little bit crazy, so that's fun. So we've got value pos is, or rather value mask is 1 shifted by bit, right? Because that's in the low part of, yeah, that's in the low part of the byte, or it should be at least. And then change change mask is 1 shifted right by 4 plus bit. That's right, left by 4 plus bit. So the same bit in the upper nibble, giving us data and percent value mask shifted back down by bit. Ooh, shiny. Just be careful. Indeed. JKIV gets it in 1. I think because you are worried about those things, you're fine. So if we do this... Cool. Our applet doesn't crash immediately. What do we need to still tie together to make this work? We need to finish writing the sub-target. So we've got the bus. We then have the event adapter. That should hook the FIFO up. Just go check that that's the right kind of thing. Yes. Except I've misspelled adapter. It's adapter. Oh, okay, so it probably would be OR in British English, which is what I speak, because I am, you know, a Brit, unfortunately. But I'm going to go with the spelling that White Quarks used throughout the codebase. Ah, okay. Interesting to know, Steffi. Thank you. So the JTAG probe state machine is showing that yes, I was correct to make that combinatorial. I hate it when language does that. No fair. Anyway, so we're just hooking the data for the FIFO up directly to our data signal that we're generating, which is fine. And then, yes, this correctly now pulses the write enable for the FIFO whenever we have data that needs writing, and it is writable, which should, by the looks, do the trick. Today I learned. So we've got it all hooked up in the sub-target. Good. We have the interface written. We create the sub-target. That's all happy. And then we build the interface, interaction arguments, and interact. Ah, right, that's the other part I need to do here. We pull out all the data, and that's all great and happy, but we don't currently put it in the VCD. So this is change TMS JTAG-PDI. Oh, hang on, this is okay, so this should be signals 0. I hate this. I kind of want to do this better. Let's do TMS signal is signals dot, VCD writer dot register var scope double quote name TMS etc. So that gives us TMS TDI TDO SRST. Okay, I feel much happier with that because then we don't have some implicit weird shit going on. Cycle and TMS.value. TDI, DO, SRST. So SRST, TCK is, each step in the VCD is a full cycle of TCK. I haven't got a real good way to encode TCK right now. But I don't think I care because I really only care about the value changes, which means that if we look at the value changes at every 1 nanosecond, we know that is one step of TCK. It can, yes, which in our case is actually going to result in the VCD being shorter, which is kind of nice. Actually, that's plus equals 1 because this is true, but at the moment I can't even get a trace, so let's get a trace, and then we can add TCK back in once we've got the ability to see what the crap's happening. That's my thinking, at least. So we're saying port A, mirror the voltage, pin. Well, actually, those pin assignments are actually correct by default, which is nice. Direct multiplexer interface has no attribute getPad. Okay. That's this here. It was getPads before. Yes, it's still getPads. It's just instead of using pin sets, it's using pins. Okay. Ooh. Oof. Oh, right. We need to create the clock domain before this point, or... I know how I can fix this, but it's a little bit janky. But that's okay. Yeah, so we now have the interface, get 50, and we've got the clock domain now. That means we get rid of the self there, and self there. I think that trickles all the changes required through. Is it that then? No, that is instant CD logic clock domain. Name should be automatically set to JTAG because that's the domain I'm assigning to, and it knows that. How is this supposed to work? I don't get it. Domains, CD logic, whereas the crossbar side is on its own clock domain, which is fine. And the CD logic should be coming in, yes. Is it happy if I do that? Yes, it is. Kind of. Oh. I have to create the clock domain all the way out here and pass it on in. Oh my goodness. Hi, welcome. I am quietly going, or not so quietly going, completely cuckoo right now as I try and make NMyGen happy. I'm guessing from the nick that that's Nico. Awesome. So sub-target then needs that, and then we can then pass in FIFO JTAG-CD. This is horrible. I'm having to pass a clock domain around. So I can finally, at this stage down here, assign it to a domain and use it. Did that make it happy? It did! It's kind of working. Namespace subject has no attribute pull-ups. Why not? Gpulls is a mutually exclusive group added to the parser. Pull-ups, pull-downs. Line 164. If arg.pull-ups. That very definitely should be the name of the variable. Not that this is correct anyway, so that's going to be fun. But we can currently comment that out. You're very welcome. JTAG analyzer output object has no attribute event sources. Yes, that's because that shouldn't be taking event sources. It only needs the interface. That's right. Okay, we are going. Let's see if that worked. No. But not for the reason I was thinking it would be. What is a memory view when it's at home? This is a good problem to have, actually. So, decoder is a trace decoder. Trace decoder has a process call for octet in data. Ah. Okay, I see what's going on here. So this actually needs to be for byte in that. And then this needs to be two-staged. We first have the getting the data. And then once we've... Yeah, okay. I kind of get what this is doing now. This makes life a lot more complicated, but hey. Well, that explains this weirdness. Oh, right, okay. That's even better still thinking about it. Interesting. So what we're going to do here is we're going to read out a bunch of changes that have happened, because this is how the system works. And then provide in that do the thing. Which actually, ooh. Can I await on a generator and then do yield? Because that gets rid of another whole layer of blech here. I think I want to do that. I have no idea if that'll work. But this should be interesting. Async generator can't be used in a wait expression. Aww. How does Python async yield work? Oh, I could return from the async function, I could return a generator. Ah, that could work. Def process. And then that's now gonna await on a generator and then return, sorry, await on stuff to happen, return the generator that, yeah, okay. Let's see what happens. None type object is not iteratable. Why is that a none type? Divide in wait that. Oh. Whoopsie. Function object is not iterable. Well, yes, because it's supposed to be returning a generator. I'm getting the memory view again. Why is that giving me a memory view? I need to understand some more about this then, I guess. Because Whitequark is quite happily doing the thing that I'm trying to do. Oh! I'm silly. I create on octet here and then I don't use the darn thing. That's why. That might have worked. Let me clean out memory. We have a big enough trace file. Ooh. Oh no, I can just go straight to GTK wave because I did this the somewhat sane way. So I got TMS, TDI, TDO, SRST. This feels like I might have got the signals backwards, because SRST there should be high this whole time. I think. Which we don't see happen. Well, that's easily enough fixed. It does look like something. I'm not sure what I'm making of the something. Especially as it feels like almost all this logic is inverted. But what I'm gonna do, I think, now... well, what I was going to say is, what I'm going to do now is I think I'm going to go and grab my oscilloscope and see if, for example, if I can get a trace with TMS and TDI that agrees with this VCD. So we're going to do a run with my scope running, probing TMS and TDI, and we'll see if we can get the two to agree. If we can, we know we've got a good trace, right? If not, then it does look like a signal cap, but it's whether or not I've got this bit decode right and which things are what. Particularly as SRST is being held low, which I wasn't expecting. But could be right, to be fair. That said, I have just realized we never tell... Oh no, because the first thing that it will do is it's when it sees the first value changes when it first does a report. Right, so yeah, that's fine. It's almost like I want to send a second byte, which is the TCK state or something, because this is where I could benefit from having actually captured TCK, which I didn't do. One moment while I rearrange my desk so I can put a scope on here. Yeah. How do I want to do the probing? That's the other question. I think what I want to do the probing here is solder a couple of wires onto the breakout board. So I'm just going to quickly unplug the JTAG chain. And pull the board out. I'll do a little bit of quick soldering, so I'll get my iron back out as well. Before I change where power is going. Don't worry, I'll change what you can see in just a moment. Okay, so this is the little JTAG board we've been using today, and we're going to tack onto here some magnet wire that will partially strip so we can put some scope probes on here. So we want PDI TMS, which are the first two pins over this side. Oh, I need to grab some flux, not flux, sorry, solder. And not have my flux pen keep rolling. So I'm currently just stripping the wire a bit, because this is enameled wire. That wants to flick everywhere. That's quite annoying. Let's put a bit of flux on the wire. Springy springen. Yes, I also just put flux all over the board, but that's fine because we'll need some on there anyway. Just probably not where I went and put it. There we go. Takes a little bit of working to clean it. Oh geez. That's quite the equation. So this is... this should be TDI that we're going to first wire to. If I can get the board to hold still enough. Ah. Well, that's annoying. The board moved as the solder was solidifying. I'll have to try and get this set up better. Come on. Ah, interesting. Cursed. Interesting. Okay, there's a joint. It's not a very good joint yet, but there's a joint. Handy. Ah. This is the problem I get. The board wants to wander. And I can't keep hitting the pin. Damn it. Well, I guess that'll do. We now have somewhere to be able to put a probe on. Yes. I need my snips. Okay, so there's our first probe. Well, it's getting quite toasty in my fingers there. Because, you know. Hey Amy, welcome, welcome. I'm having JTAG issues, we'll call them. So we're having to currently build a custom probing rig on top of the JTAG interposer. So this is TMS I need next, which is the next pin along. That's going to be hilariousness when all plugged in. What I'm trying to do here is I'm trying to use the existing header to help me hold everything in place. I'm actually going to use my tweezers to hold things where I want them this time, which helps me hold the board better. when I don't put my finger in the wrong friggin' spot, that got hot very quickly. Okay, so there's 2 probe points. Which, there we go, so we can get some probes on those. And we also need grounding, because otherwise probing setup will not work. So we're going to put a couple of these back pins, which are all ganged together anyway on the board as big ground the whole way along here. And we're going to get some wire on there so that we have somewhere to put the ground probes. This is not a good probing setup. It is, however, a probing setup. You can't really see what I'm doing right now. Whoopsie. So I'm currently trying to... work my way along the wire. Taking off a decent amount of the insulation. That gets hot in a hurry. There we go. I'll clean my desk before I go further, because that's a lot of solder shrapnel. Which we do not like. We do not at all like solder shrapnel, because it conducts and gets everywhere. Quite literally everywhere. Yeah, I should have done that. I had space on the traces, kind of. It's a little difficult because I've got some stuff on this side as well. For signal integrity reasons, the traces go from here to the header, and then back out to the, to there. Yes, you're very welcome to ask me miscellaneous embedded questions. I will do my best to answer them. Okay, that's created a joint between a couple of the grounding pins and this piece of wire, which is going to take clips. I'll be very honest, I'm entirely self-taught, and I structure my code in the way that most makes sense for the project and its data flows. For example, MXKeyboard is entirely interrupt-based at the moment. Whereas something like SpyFlash Programmer does actually have a main loop. It really depends on the exacting nature of the project as to how I will go about structuring things. Okay, so this should give us sufficient length to be able to put a couple of ground probes on, and then hook scope probes to 2 pins we're after. I guess what I'm saying, plate element, is that I structure my embedded code as if I were writing a desktop program, but with the recognition that I've got interrupts there, which are basically like threads or coroutines, and using the same kind of synchronization idioms, but obviously instead of being able to do a mutex, you're going to have to build your own using atomics and there is no, I will say this, there is no right way, or rather there is no one right way to structure an embedded program. So I do it in a way which I can see is correct by construction. Which is honestly the best I've got for anyone. Try and make your programs correct, provably correct by their very construction. Which, if any of you in chat have done formal methods, you know exactly what I'm referring to. Well, yes, essentially, Obliterus, you're not wrong. But there are different kinds of works. There's works just because you got lucky. How do we know? And then there's works because you wrote it in such a way as you can prove it will work. Which means doing things like avoiding undefined behavior. You know, because the compiler can do whatever it wants with it, UB. And that in embedded frequently means your code gets optimized out. Why did my firmware image suddenly get 50% lighter? Oh whoops, I UB'd. You know, that's not a great look. Just putting power to my scope. Is it that way around? No, it's that way around. Cool. While that boots, let me move the camera real quick. So, here's my horrible setup in all of its glory. And let's put this board back. We'll plug that back in, which should go this way around. And then we'll plug this back in, which should go this way around? Yeah. And we can see the green light. Yes, but Arduino didn't think properly about trying to avoid UB, and they went, oh, we'll use C++. How hard can it be? Hard. Very hard. Yeah, there's a lot of undefined behavior that goes on in Arduino, unfortunately. Oh, I managed to lock the power cable from my camera into the JTAG loop. Nice one. That's honestly a good place to be. If you hated Arduino, this is a good thing. In my honest opinion. And I'm... Yeah. Oh, this is true. This is true. Okay, so we have scope up. Let's get some probes out and hook them up. Let's see what we can do. Fun. So, yellow is going to be channel 1, which... did I ever dump the help out? Yes, I did. Channel 1 is TDI then. Well, ooh, yeah, let's make channel 1 TMS, not TDI. Okay, that's a nice clean logic level that I see. We have no idea what timescale any of this should be on. That's going to be fun. Also, instead of doing a programming run, this time around I think I might try and get a trace using my virtual machine, which has been running this whole time. As this will slow down the amount of wear on the flash of the microcontroller, because I really don't want to have to replace the micro on this board. Okay. So we have 2 clean logic levels. I'm just repositioning things on my oscilloscope display. Let us set triggering up real quick. So this is 3.3 volt logic, so I want a trigger point of... This isn't using a T/C, this is using a ATX Mega. The other project is the T/C, which would be the one I wouldn't need to reverse engineer the JTAG for. Because TIVA JTAG is actually well understood, but this JTAG isn't. Which is fun. So, rink. Okay. I'm just setting my trigger up to be mid-signal, and let us put this into single shot mode. And this will be debug.vcd. Now before I set that going, alright. Oh, for fuck's Windows bloody updates. Hey, no, you're not. I hate it when Windows does that. Okie dokie. Take care of it. Oh! I see. I misread what you said. Why is that the most recent project it thinks it's opened? That is not the most recent project it opened. Windows just rubs me the wrong way in every conceivable possible way. I hate Windows. Okay, that's a fun problem with my audio stack that Windows just caused. That is a very weird problem with my audio stack I'm getting. Interesting. Windows is very painful, yes. Is the audio okay for you, or is that just me? I paused it for a moment. Okay, so that is entirely my end, then. Wow. And if I pause the Windows virtual machine, it's still messed up. That's great. Yeah, it's on my end, and it's to do with Pulse Audio and having a very bad interaction with this virtual machine, which tried to make noises, which screwed up the sound. Yay! I'm having pulse issues, yes. Cool. Thank you. You're the best. I really mean that. You are actually the best. While she's doing that, let's find the firmware entry point, because I'm going to do some step through. There we go. Can I set the alternate sample rate higher, or is that you have to have the two matching? Because my sound card can do 441 and 48. Okay. Huh. Need a console. I'm going to pause music play before I kick PA, and then we'll see what happens. This should be interesting. Okay. Let's see if this breaks things.